Hey everybody, welcome back to the last lesson of Stoich, which will end up being the last lesson of the Chemistry 20 course. So we're going to be taking a look at chemical analysis today, which is a very simple concept. Before we get into that, we're going to do a little bit of review on excess and limiting reagent. So review. The following reaction, ammonia reacts with oxygen gas to create nitrogen monoxide and water. In an experiment, 3.25 grams of ammonia reacts with 3.5 grams of oxygen. Determine the limiting reagent. Okay, so first things first, we take our reaction and we need to balance it. Oh, nope. No. Yep. Gas plus water. If we balance this, it'll be 4, 5, 4, 6. Highly recommend that you pause, you balance it, and check your answer. Then from there we list what we know. So in the pink, I'm going to do ammonia, which is 3.5 grams. Wow, that was written so badly. Can't wait to retire this stylus. And it is reacting with 3, oh, sorry, 3.25 grams. 3.25 grams of ammonia, and in the blue, I'm going to write 3.5 grams of oxygen. Now we need to determine the initial input that both of these are putting in. So I'm going to start off with ammonia in the pink. So 3. Ammonia. Start off with 3.25 grams. Wow, I'm just 3.25 grams of this. We need to convert it into moles, so I'm going to use molar mass. The molar mass of ammonia is 17.04 grams per mole. So I am going to divide by 17.04 grams per mole, and then you need to divide by its coefficient, so by 4 moles of ammonia. Should say ammonia there. Let's do some canceling. Grams and grams, moles and moles, ammonia, ammonia. It gives us a nice unitless number so that we can compare it. This is going to give me 0.0478. Great. And then the next one I will do in blue. 3 oxygen, 3.5 grams of oxygen. And then we are going to divide by its molar mass, which is 32 grams per mole. So we go 32.00 grams per mole divided by 5 moles of oxygen. Let's cancel things out. Grams and grams, moles and moles, oxygen and oxygen gives us a nice unitless input number, 0.0218. This here is bigger, so this is my excess reagent. This here is my limiting reagent. Perfect. It's gonna Alrighty, so from the above, we learned that our oxygen is our limiting reagent. In B, it's asking us to determine how many grams of nitrogen monoxide is formed. So we're obviously going to use the limiting reagent, which is going to be our oxygen. So I'm going to get rid of this so it's just not conflicting information. We are looking for grams of nitrogen monoxide. So to find that, we're going to begin with what we know. 3.5 grams of oxygen. We are then going to convert that into moles, 32 grams per mole. Once we have moles, we can then use our mole ratio, which will be 5 moles of oxygen to 4 moles of nitrogen monoxide. Mole cancels out with moles, oxygen cancels out with oxygens, and you're left with moles of nitrogen monoxide. Lastly, you're going to use grams and then convert that moles into molar mass. You're going to use molar mass to convert it into grams because that's what we are looking for. The molar mass of nitrogen monoxide is 30.01 grams per mole. So you multiply by that, and moles cancels out with moles, and you're left with grams of nitrogen monoxide. Once you plug that all in, you get 2.63 grams of nitrogen monoxide. Okay, the last question, how much of the excess reactant remains after the reaction? So we know that our excess is this guy. So in order to find out how much remains, we actually need to find out how much was used first. So we're looking for grams that was used. So I'm going to actually grams used. So in order to find the grams used, we need to use our limiting reagent to see how much of that actually reacted. So you're going to start off with your limiting reagent, 3.5 grams of oxygen, 32 grams per mole. Then you're going to use your mole ratio, 5 moles of oxygen, 4 moles of ammonia. Moles cancels out with moles, grams cancels out with grams, oxygen and oxygen. Then from here, we use molar mass to convert it into grams. So now moles cancels out with moles, and I'm left with grams. Calculate that out. You get an answer of 1.49 grams of ammonia. So this is actually how much was used or consumed in the reaction. Now, to find how much is left, you're going to say, so remaining is equal to initial amount. And you don't really need to use this as a formula, but I'm just trying to visualize it for you, minus the consumed or used amount. So we plug that in, that's going to be 3.25. Make sure you're selecting the right mass. I am selecting this. This is my initial. Okay, minus 1.49 is equal to 1.76 grams of ammonia remains. There is my final answer. Okay, let's wrap up this unit. So, to summarize, there are 3 predominant methods. for a chemical analysis. So, one second. So 3 predominant methods for chemical analysis. The first one is gravimetric. Sorry, we'll call it gravimetric analysis to be more precise, using Stoich calculations from a measured mass. So this is how we started off the stoichiometry unit. The second type is called a titration analysis, using Stoich from a measured solution volume. And lastly, the one that we have not talked about yet, actually a little bit, we have talked about it through indicators, through solution colors, is colorimetry. This is more of a qualitative analysis by observing the colors of a solution. Oh, this is really bad writing. So, okay, hold on. Colorimetry solution by using a flame test. So we can do colors of by looking at the solution color, or we can do a flame test as well. Colorimetry. Let's go into more detail because we've already explored the other one. Flame test is conducted to determine unknown metal or metal ions in a solution. So we're going to go and use our data booklet on page 6. You see we have this flame test color of elements here. For example, use page 6 in your data book to determine the metal that burns yellowish red. So the yellowish red, I look across and I see that that is calcium. Qualitatively, we can also determine the type of ionic species or ions dissolved in a solution by using page 11 in your data booklet. Right here. For example, 1 molar solution of iron 3 would be, so we're going to find iron 3, and 1 molar would be orange yellow. And 0.01 molar of iron 3 would be pale yellow.